the types of the model split. So in this types of the model splits, the first one is the trip and uh, first one is the trip and model split models, and second one is the trip interchange model split models. Third one is the aggregate and disaggregate models, and fourth one is the binary logic models. Okay, so in this first one we will see the what is the trip and model split. So here the main objective of this transportation planning, so that has to forecast the growth, so what growth will be there in future, so that in a demand, so for the car for a car trips, so that has to be forecasted. So in that investment, so that could be planned to meet the demands. So whatever the uh, money we invested, so all this has to be uh, meet the all the demands which is required for the future. So that for that proposed characteristics, whether the thoughts to be most important determining for what type of the mode, for the choosing of this mode, and attempts, whatever the attempts that has to be more made for um, other types of the modes and other type of the models. So in the trip end, the model, whatever the models are there, so that has been splitted in a such a way that there is a different in characteristics of the persons. So one person to another person, the characteristics will get varies. So in order to pursue this, to estimate the exact not exact, the approximately the future growth more demand, so that demand these models splits for the time, so that is been related to the choice of the mode by the individual person. So that future income and their density or population in the area, and the number of the vehicle ownership, so that based on all this, the models has to be done. So forecasting of the growth has to be done by the various models. So advantage in this split in the models is that the whatever the models are there, that could be very accurate in the short time. If the public transportation that is been available and there is only a little congestions are there the limitations is that there whatever they are insensitive in the policy decision. So if you take an example like improving the public transporting, or the uh, rusticating the some parkings, so that would have no effects on the model splits. So the forecast is only a small change in the policy in the decision making, that is sufficient. So that's about the this model splits for the time which has been related to the choices. So that's about the trip and model splits. So next we will go for the second one, that is trip interchange model splits. So what is this trip interchange model splits? So in this trip interchange model splits, so this what is this model is, that is particularly for the this model is used only for the distributions. So distributions of the trips whatever it takes, so to find out this trip distributions over the stages. So one stage to another stage, the trip may alters. So consider, so one point, so from so there is a stretch of 30 kilometers means, okay, in that stretch of 30 kilometers, so one stretch you can go by train, so another stretch there is no trains, so availability of train is not there. So in such cases you have to go by bus. So they changes the model, the distributions changes. So this has to be take advantage such that whatever the possibles, so that includes the characteristics of the journey or that of the alternative modes which is been available to understand or undertake such possibilities. So in that possible ways that includes the decision in the policy making. So this beneficial will go for the longer term. So this beneficial is not a for a shorter durations, so it will go for longer term. So that's why the whatever the trip interchange model split is very important for the policy making for the longer term. So next we'll go for the aggregate and disaggregate model. Third one is aggregate and disaggregate. What is this aggregate and disaggregate model? So here the whatever the choice of the mode, okay, so that can be aggregated, so that may be changes from zone to interzones, from interzone to zones, okay. So you can go by one by your own vehicle to some extent. Later it is not possible to go by your own vehicle, so you have to take the public vehicles. So the mode of the choices will get aggregated, so it will get changes from zone to interzones. So that is what the choices. So that it is then the changing from zone to zone mode of the choice, that will be changes. So that is disaggregated. So that is based on the household, or that is based on the individuals, so based on the circumstances. So that's what the this about the aggregate and disaggregate model is about. Next we'll go for the binary models. Okay, this is the binary logic model, so very important. That can be asked for the examination directly. So binary logic method. So here in this method, so this is the very simplest models for any one choice. For whatever the traveling may be, so that is between origin to destinations. So this model is that is very simple to made. So here the whatever the travel, so that will be associated, that will comes for the value for the transportations. So you for a 10 kilometer, an expenditure of if consider if the car gives the mileage of 15 kilometer per liter, and the cost of the diesel, if you may cost around 75 rupees means, so 15 kilometers 75 rupees has to be paid. So if you go to the private vehicles, so that 15 kilometer may take around 15 to 20 rupees. So this difference, so difference between these the value for the transportations we have directly, or which has to be divisible, or discretability also, or the here the whatever the travel cost, that should be represented in the model, okay. So take a different modes. So in the different mode, so what is the cost for the transportations, so that it has been represented by the general equations. So that equations looks like this. See here, this is Cij is equal to a1 Tij to power of v, a2 Tij to the power of w, a3 Tij to power of t, a4 T Nij. So like that, plus a5 Fij. Okay, so it gives Tnij, Fij, and a6 F0 plus delta. What is this first of all, what is this Tij? So this Tij, very important, okay. First there is a Tij, next is Tij w, it is power of v, w, and t, okay. So here Tij to power of v, that is in vehicles. In vehicle travel time between I to j. I is origin, j is a destination. Next is Tijw. So that is the waiting time. Waiting time to and from the stops. Okay. So next is Tijt. So next is the waiting time. One is waiting time to go and or to come to the stop, and another is waiting time to at the stops to take the another vehicle. Next is Fij. So that is the fare or charges. So charges for the travel between the origin to destination. Next is 5j. 5j is nothing but uh, 5j is nothing but here a1, a2, a3, a4, 5, that is I will tell you later. So here the important is 5j. 5j, that is the parking cost, and delta is the parameters. Parameters for the representing for the comfort and convenience. Here the if the travel cost is low, then that is been made for more probability for the being for chosen. So that can be taken easily, that model. Here there is a two models, so consider 1 and 2, that is proportions of the trip mode from the mode 1 from zone I to zone J. Next is another where the cost of traveling for the zone I to zone J using second model. So where the cost of the traveling zone from one zone to zone J, here there is a some cases are there. Okay, so that cases I will explain. Three cases are there. Okay, here the first one is from traveling from second mode to first mode. So positive, it is a positive when there is a mode is one is chosen. If the Cij 2 to Cij 4, so that is negative where there is a mode 2 is where the mode 2 is been chosen. So that is the second one. Where in the third case where Cij 2 minus Cij 1, so that is equal to 0, then the both the whatever the both the models are there, that is equal, so you can choose any one. The probability will be any one. Okay, so that this relations, whatever this relations are there, so this relation fundamentally that is being taken and represented in the forms of the proportions of the trips from the mode 1. So that this been written as like this: Pij is equal to Tij divided by Tij. So that is equal to e to power of minus beta minus beta Cij divided by e to power of minus beta Cij plus e to power of beta e to power of Cij to power of 2. Okay, this is 1, this is for 2. Okay, second mode. So this is what the fundamental form of the equations for the logic. So where Cij, that is called as general cost, where p that is been called as parameter for the calibration, where the graph in the considered that is there will be a graph will be there. So for that calibration, so p will be taken into considerations. So that has been taken by the graph of the proportion of the trips from the mode 1 and against the cost differences. So by that it will be taken. So that's about the this method of binary logic method.